Hi, I'm Professor Dow. I'm discussing the Solid Mechanics 302 lab today, the different projects that we do. The first one is the machine in the far corner there. It's the tension testing machine. We pull on a sample in tension, not compression. We just pull on it, and not just linear or elastically, but all the way until it yields, goes through a yield plateau, goes into strain hardening, and then ultimately fails. We measure the force, and then we also have the next tensiometer, which measures the displacement. Force divided by area stress, and then the strains are measured by the displacement divided by what we call the gauge length. And so that's one experiment. Students learn about modulus of elasticity, yield stress, and other important information about not just steel materials, but other materials. The next machine over here is torsion testing. And so we take a cylinder and we twist it. It's like taking a carrot and twisting it, and you see a spiral crack and failure that develops. And we have strain gauges on there that measure, they're put on at 45-degree angles in two directions, gives us tensile and compressive strains. They're principal tensile and compressive strains. A third experiment over here is a Poissons ratio test. We pull on the member in tension, and this is a little subtle test because we pull on it in tension and the member sucks in. It actually shrinks in the other direction. So we have strain gauges in the vertical and the horizontal direction that students learn about this concept. And it turns out it's important in various structural engineering applications. Over here we have a displacement, and that's it's a beam, an I-beam, that we apply loads in different locations and measure the vertical displacement is also at different locations. And in this case, it's interesting because we're using dial indicators. So these are mechanical devices to measure the displacements very accurately, not digital. And we compare that to the solution that we know from structural engineering, which is a differential equation, a mathematics equation that we can solve and compare to the displacements. And you get within 1%, so 99% correct results there. Another test that we do is down at the bottom in the big pit. We build a big wooden frame. The students help build it. It's about, 8 feet tall, 4 feet wide, 2x4s nailed together, and we test that to failure all the way down, and students learn a lot about structural applications in that case. And then one other thing that we do is we do concrete cylinder tests. First, one lab is to build the concrete cylinders, build them in the forms, and follow the right procedures to cure them. And then over the next few weeks, they test these concrete cylinders to understand concrete strength increase over time.